All right, now I want to solve that unit step function or Heaviside function idea on Sage. So what I have here is I have that original script that we just did a bit ago with our x double prime right here, 4x prime, and then minus 21x. Now before we had equals e to something or other, but here I've just put in the unit step function, so it says unit underscore step of, and remember it was 3, it changed it 3, so I said unit step of t minus 3, and that'll shove it over so that it's 0 until it hits 3, and then it's 1 after it hits 3. So I just put that in. Everything else is exactly the same, and I hit evaluate. Now I already did that, and here's what happened. This top stuff looks great. Hey, it took the Laplace transform. If we move over here, we see that Laplace transform is e to the minus 3s over s for the unit step function at 3. And then I had done that same thing of substituting in the initial values. Okay, that was great. And then I solved for the Laplace transform and got this whole big thing here. So that's great. And then I took the inverse Laplace transform and I said, what's that? And according to Sage, it is the inverse Laplace transform. That's all. It didn't do anything. It got confused. It didn't know what to do. So what I did was I thought, well, okay, looking at this, the problem might be, notice we've got e to the negative 3s here. Here's e to the positive 3s, and it didn't multiply through. Okay, so that maybe is the problem. It didn't multiply through. And so one thing you can do in most of these computer algebra systems, like Sage, you can ask it to expand and collect and various things like that. So I thought, well, I'm going to try expanding this whole expression and see what happens. So I put in this command. I said, well, instead of x, the Laplace transform over here, I'm going to call it x expand. Doesn't have to be that long a name, but equals, and I said x dot expand. So here I want to expand the original x, and I'll show that so we can see what it looks like. And we come down here and notice that, see, it did look like this up here, there. It looked like that. Now it looks like this. Oh, well, maybe this will be much better. I mean, I've got that s squared over this, 4s over that, and then the e to the minus 3s over all this. Okay, so awesome. So I'm going to then try this again. I'm just going to copy those two lines, put them down here, but now x needs to be the x expand variable right here, and then solution's the same, so I evaluate. And I made progress. Didn't win, but I made progress. Okay, so these first two parts of this thing up here, the s squared and the 4s part, it took care of those just fine, and that looks correct. But now this doesn't look good, and I think the issue is I probably need to do a partial fraction of that denominator. Well, I could type some things in by hand and get the partial fractions, and then multiply through by e to the minus 3s and do an inverse Laplace transform. So I can do all that. What I'm wondering is, well, can I do it without doing the brute force? So, when I say brute force, what I mean is let's just try a show just to see if this works. And what I need is that partial fraction again. And of course, I can't remember these things very well, but I think what I can do is if I take parentheses, and I have to look at this. See, this is the problem. S cubed 4s minus 21s. So 1 divided by s cubed or s squared? S cubed. Oh yeah, because it's got that other s term in it. S cubed plus 4 times s squared minus 21 times s. So there I've done the division, dot, partial fraction. I don't remember if it was plural or singular. Close that all off, and let's just see if I got this to work. I just want to see the partial fraction there. And it did it. Yay, I recognize that. Okay, so there's that partial fraction. So see, this is the brute force part. So I can do that partial fraction. So instead of saying show, I'm going to set that equal to, I don't know, PF for partial fraction. Equals that, get rid of this parenthesis. Then I am going to, I don't know, do something like x nasty part, just x nasty, I don't know, could be a bad thing, is equal to what we have there, e to the minus 3s. Okay, so e to the minus 3 times s, and then times that partial fraction part. So I did that, and now I just want to do, I'm just going to say show the inverse Laplace transform of this x nasty part, dot inverse Laplace transform. So I'll just go up here and do that. Copy that, put it there, and evaluate that part. And you see it still didn't do it. Bummer. Okay, well, one more try. We'll do that nasty part, dot expand. Now see if it'll do that inverse Laplace transform. Wow. It is not doing so well. So it doesn't seem to know, and I'll have to investigate this myself, but it doesn't seem to know how to do that inverse Laplace transform. I do. We did it already in the video. I'll have to do a little more research to see if I can tell it how to know to go to the unit step function with these, but it appears it doesn't. It doesn't know how to do that inverse Laplace transform with the unit step function. So I'm going to end this video here, and we'll see if I can figure out how to make this happen. If I can, I'll add another video. If I can't, well, that's the end of this video. So we'll stop there.